We're group 5 in the ME444 class, and this is a presentation for our toy, the trained dragon. I'm Leo.
I'm Brendan.
And I'm Kyle.
All right. So starting out with the idea, we wanted to make a mechanical sort of Asian dragon. And how the Asian dragon works, it's kind of swirling through the air in a pretty complex manner, sort of like you can see here in the little video. So we wanted to do something mechanical to get this movement. And this would have, be directed towards anywhere between just kids or adults. It would sort of have like an aesthetic feel and a collector's value, made out of wood, so it would feel pretty nice. And also with the mechanical enjoyment from seeing how it works, and just playing with it should be relaxing and make you feel good. So the uniqueness of this toy is, you don't really see so many Asian dragon toys, not that I've seen anywhere. Mostly you can see maybe the Western dragon with big wings and stuff. So it's a bit different. Also, like I said before, by being able to see the mechanical function should make you interested in how it works, and make you kind of, it also, you want to know how it works, so it's educational for kids, or you get interested in it and want to see how it works. So going into a little bit about the key features of the CAD design that we made. Here you can see the picture of how it looks. And first of all, we had to kind of reduce or simplify the mechanical function, because the original swirling movement that we wanted was a little bit too difficult to get. So we kind of just reduced it to only the up and down motion. And how that works is we place these cams on an axle with different angles, and each of these cams individually would push up a rod up and down, basically when you move the hand crank. And on top of these rods, we would have the dragon, which was the head and 6 individual body pieces, all identical, and then swirling tape. Also, an idea we had in the end was to add music to it, sort of like a music box idea. So how it works, every time one individual cam revolves around, it would ping off a bell or have some kind of music touch, which would make a noise. And then, since there are many different cams, we could make a melody out of that. And also something we later added in the physical model was another feature for the head that made it move to the right and left as well. So a quick illustration here how it works. So you see, you pull the hand crank, and the dragon does the swirling motion. And here you can also see how the cams are interacting with each other and creating the pattern, the flow pattern of the rods. So that was a little bit about the idea and how the CAD design was developed. So, but now CAD is going to talk a little bit about how you go from CAD to manufacturing and prototype.
So for our group, we kind of use CAD for two major benefits. The first was kind of just visualization of our first initial concept, and kind of what we kind of wanted to stay true to throughout our entire design as we modified it to fit the problems that we encountered. And the other was to be able to rapidly modify it to fit the constraints of the project by the dimensions of the base that we use for laser cutting, and for 3D printing constraints on materials, we had to remove mass from some of our parts in order to meet that constraint. So it allowed us to quickly change that so we could easily fit that. And then when we went into the manufacturing, we used the CAD kind of as a plan or a framework of how we wanted to get the parts made through either laser cutting or 3D printing. And then from that, we kind of saw these difficulties and problems that kind of came when kind of transitioning from that phase from CAD to the manufacturing. The first was kind of these hidden problems. We needed friction, but we didn't need too much friction in our thing, and CAD kind of doesn't really allow us to kind of add that into it, because all the parts moved smoothly in an ideal situation. So we had to figure out kind of how much friction we wanted and how that would interact with our toy as we moved it around the axle. And another would be the hole sizes. When manufacturing, if the hole size is slightly too big or too small, it could affect the functions of the design in a major way. And we'll get more into that later. Another is these kind of non-feasible features. In CAD, you train each of the parts to be in a set direction or a set motion, where in the real world it's kind of free, they can move in any direction, and you kind of have to use the other parts to constrain it or use supports and stuff like that. So we transitioning from like the rods to before it just didn't work out with just the rods. And another would be holding through the side here is trying to do that in a manufacturing facility is kind of difficult. The holes can either turn out too small or too large or not even circular at all, which then creates errors in the function of the product that you're making. Where in CAD it kind of just looks perfect and it works just as intended. Another would be the material properties. When designing between wood or metal, you kind of have to have an understanding of the manufacturing processes that you're going to use, and kind of how you want your kind of toy to function as a whole. Because if you use metal, the weight would increase and make the toy heavier, but if you use wood, it may not be as strong if you need to be in a strong location. So Brendan will go into how these problems arose in our project and how we fixed them.
Thank you, Kyle. Wait, that's the wrong one. There we go. Okay, so I'm going to talk about the physical prototype itself and the iterations that we went through to create what we see in front of us today. So iteration 1 involved an initial base assembly and then the rod assembly itself. So the base being everything that's painted black here, and then the rod assembly being these vertical rods that are attaching into the dragon pieces. Now, we had created these and put them together and realized initially that this top piece had holes that were too big. We had given too much clearance, so these dragon pieces were moving so much that we knew they were not going to stick onto the cam system. So before we continued with assembling everything else, we wanted to redesign the base. So we went back in, and instead of using the laser cut base that we have for the rest of it, we hand cut the top part and thickened the size of it as well to allow for more stability. That way the vertical rods don't move around as much. We tested out different hole sizes to see which one would work best. That way the dragon pieces are willing to move upwards, but then also naturally fall downwards down afterwards. So that is what we did for iteration 1. Into iteration 2, we rebuilt the base, like I said. We assembled everything and then also created the cam assembly, so the rod shaft through the center with all the cams on it. And the next big problem arose that the vertical rods did not want to stay on the cam shafts. The way we designed this was kind of with an egg-shaped cam. And in the video we saw earlier, all we have is a point following that egg-shaped cam around. In the real world, that doesn't work out as well because all it takes is one little jiggle and it falls off the cam and jams the whole system. So stuck at this point, we had to decide how we were going to fix this problem, and we come into iteration 3, which involves fixing some of the cam issues. We added blades to the bottom of each of these vertical rods, which allow the cam to stay in contact during the entirety of the rotation, which allows it to have much more smooth motion. One problem that did arise from this, though, is that these blades like to move side to side, which would then interfere with each other and then jam the system as well. So to fix this, we added different pronged elements going up and down to hold these blades within a little channel. That way they wouldn't interfere with each other. So we also added some paint to make it, give it that aesthetic feel that Leo talked about. We want this toy to be appealing to our audience, and so we thought we would paint it and kind of give it that feel for collectors and whatnot. And now we get the final product from all of that steps. A couple things we wanted to address with this. As we were building it, we decided to negate the musical component that we had originally looked at in the beginning. The idea was kind of to use pressure to fling a metal piece to create that sound, but after having so many cams on here and requiring so much force already, especially if we're applying this to a childhood audience, we didn't feel like that was the best option to go in terms of making noise. So we did add some bells to the end of the dragon. They did fall off in transit, so they're not on here now. But we decided the musical component wasn't what we were looking for with this device particularly. The idea is that we wanted the motion of the dragon to appeal to the users, and so instead we decided to ramp up the motion of the head. We actually have a special 3-tiered cam system under the dragon, which allows it to rotate in addition to moving up and down, kind of giving it the realistic dragon feel. Like Leo said, we can't do the full motion that we saw in that video, the initial one, but it allows us to have the head move and that kind of unique motion as well. So now, we'll talk about the materials we used. So we decided to go with wood for the majority of this project because we felt that it was the easiest to work with. We had looked at using acrylic or other materials like that, but we knew that those were more expensive and this might take some trial and error to find something that worked out well. So we decided to stick with wood for the majority of the base and whatnot. We added a metal plate to the back, which would allow for better storage. If you're putting this into a shelf, you don't want the blades or the cams to contact the wall or anything else because it might damage them. So this metal piece in the back helps protect that from anything in the back. But for the top, we did the laser resin printing because it has such a high resolution and allowed the dragon pieces to come up very clean. Other than that, we used metal for different odds and ends to hold the things together and clamp the cam rod into place. So now, this project taught us a lot about problem solving. We ran into several issues along the way, and so even though it doesn't look like our initial design that we saw in the video, it does a fantastic job of creating that motion that we wanted to inspire children that we want this toy to apply to. So now, we're going to give you the toy demonstration, the moment of truth. So we see that the cams for the dragon body and the dragon tail are moving up and down, and the dragon head not only moves up and down, but also moves side to side as well. So, thank you very much. Any questions? Yes?
How did you make the head move side to side?
So there's 3 cams that are glued together. There's one that is kind of like an oval with flat sides. So that way the top part and the bottom part contact when it's the curved top and the curved bottom will contact this disc right here, and that's along the axis of the vertical shaft here. And then on either side of that, there's 2 specialty cams that have the same distance of contact zone on them, but because it's offset, when it contacts the disc, it'll turn the disc to the side in either direction. You want to make sure that it has the same distance on either side of that center one, so that way it rotates back to the center when it's done. Any other questions? Yeah.
So, you mentioned that you are going to put some music, and what do you plan to do?
The original thought was to use the cams themselves to trigger a metal flinging noise. If you know what a kalimba is, it's a typical African instrument that has different prongs that you would flick to create sound based on the length of the prongs. We realized that because there's so many cams in here and it already has enough resistance to it, if we wanted to apply this to our audience, we don't want them to have to struggle to move it. The more elements we add that would need to be moved by the cams, we didn't feel that was ideal. If we were to implement them, we would want to put them down here, so that way as the cam moves by, it would fling the element as it goes through. So one way to ideally do that would maybe put a little side rod into the cam, so as it comes around, it would fling the thing and create the noise. Thank you for your question. Yes?
Is that what those little tabs were on the bottom of the cat model?
That was our original idea, was to incorporate the metallic sounds at the bottom there. Like I said, we since decided to remove that because we felt that it wasn't going to work out for this demonstration. We didn't feel that it would be ideal for our audience, and it wasn't really the goal of our project. The goal was to create the movement and the aesthetic of the dragon, which doesn't necessarily need the sound. So, thank you. Any other questions? Thank you for your time.
Guys, please don't leave. So we have some guests from PTC here who will be interacting with you. So please make